Right, if you just move on, I'm going to move on to a question like this. This is a big stumbling block for people when you have a question like this where you've actually got to convert two different units to, and especially when it's cubed or squared, it's a very big stumbling block for people. I'm going to do is going to work through it. Now, the first thing we need to think about is not a normal conversion. We're not converting the area of something or the volume of something. We're converting two different things. We're converting the volume in centimeters and the amount of grams. Okay. In this case, it's density. I mean, wouldn't it be great if we could figure out what the calculation for density is without even having to remember what a bunch of separate equations, and of course we can. If we remember our rules on what this -3 up here means, ooh, wrong pen. What this -3 up here means. Okay, when it's on a unit, it means over. So it's the one before. So we know that if we write it a different way, the density of the granite is 2.7 grams over, that's G there, centimeters cubed. And that's something you'll have been doing already. We're just rearranging this with the power to the -3. It means 1 over, so it's grams over centimeters cubed. And it's exactly the same way as if we hadn't got the minus and we'd put a per slash here. It's exactly the same, it's just over. And we know this 2.7 is the density of this granite. So this must be density. So we'll write down density. So 2.7 equals what? Well, it equals grams over centimeters. Centimeters cubed. Well, what's grams? Well, grams is an SI unit of mass, isn't it? So it's mass. So we can write down mass. Okay, and what's centimeters cubed? Well, we know that's volume, don't we? Centimeters cubed is volume. So write down volume. And now we know the equation to figure out density. We know that density is equal to mass over volume. And you might think, well, why are you saying this? Well, it comes in very important later on when we're actually trying to figure out the numbers. So now we have this equation. What can we do with it? Well, we can use it to figure out what it is in kilograms per meters cubed. Well, the first thing we're going to do is, again, don't panic. We're going to break it down into two separate parts. So the first one we're going to look at is, let's change colour, is we're going to look at this bit. We're going to look at the grams and the kilograms. Okay, there's no cubed here, no squared, no nothing. So it should be just a straightforward conversion. So how many grams are there in a kilogram? So 1 gram equals how many kilograms? Oh, that's easy. We can look at this. What's this? Kilo 10 to the 3. Okay, and grams. That isn't a centi or a milli or anything. That's actually 10 to the 0. Okay, so 1 gram is equal to 1 times 10 to the 3. But wait a minute, are we getting bigger here or smaller? Well, it's kilograms, isn't it? So we've got to remember that the number is going to end up smaller. So it's going to be to the minus kilograms. So we now know that 1 gram is same as 1 times 10 to the -3 kilograms. Oh, that's great. We've got the first bit now. So if 1 times 10 to the -3 kilograms, well, we know the mass, don't we? We know this mass here. We know this mass in kilograms. So let's write that out, shall we? So we know density equals, okay, how many are there? 2.7. Oh, you know, it's 1 times 10. Sorry, my mistake. 1 times 10 to the -3 kilograms. Okay, so that's our conversion factor. Next thing we need to look at is this bit, centimeters. Centimeters cubed. Centimeters cubed to meters cubed. All we're going to do is we're going to do exactly the same thing as we've been doing all the way along, and we're going to convert the meters, ignoring the kilogram bit. Okay, so 1 centimeter is equal to how many meters? Oh, again, we can look back at a little chart here. I forgot what it was now. What written down? Well, meters is an SI unit, isn't it? So that's to the 0. And centimeters is to the -2. Right, so -2 is the 2. So 1 times 10 to the 2. Right, and again, is it going to get bigger or is it going to get smaller? We're going from centimeters to meters, so that number's going to get smaller, isn't it? So it's going to be to the -2. To the -2 meters. So now we know a conversion factor from centimeters to meters. And this will be done in the volume section of the presentation. All we now need to do is, because it's cubed, we're going to times, bring out colours here, this number here by this number here. Okay, well, what did we do to this? We figured out it's over, didn't we? So it's not going to be to the -3, okay, because in this case it means over. We can use this one here, which is 3. Okay, so these two link. Remember, this minus just means over the kilograms, or kilograms over the meters. Alright, so it's going to be to the 3. So we know that 1 centimeter cubed equals 1 times 10 to the -6 meters cubed. Oh, now what do we got? Well, we've got volume now, haven't we? We've got the volume in meters. And we can go back to our equation and write it in. 1 times 10 to the -6 meters cubed. Okay, so now we've got this general conversion factor. What can we do? Oh, we can use this 2.7 now, can't we? We can use the 2.7 up here, and we can times it by it. Times 2.7. Okay, normally this would be on the other side, but I've run out of space. So all we have to do now to figure out this density in kilograms per meters cubed is to do this equation. So 1 times 10 to the -3 divided by 1 times 10 to the -6 is what? Oh, you can whack that in the calculator if you find it easier. I'll write it out here. That equals 1 times 10 to the +3 times 2.7. Okay, it's positive because remember you're dividing by it. Dividing by it. Okay, so if it's minus, then it becomes minus minus, which obviously becomes a positive. So -3 minus -6 is +3. So you've got 1 times 10 to the 3 times 2.7. If we multiply out these brackets, we get 2.7 times 10 to the 3. Okay, now we've just got to worry about the units. In this case, we've got the units up here, but what if we didn't? Okay, well, we can't cancel anything out because they're different units. It's kilograms and meters. It's not 2 kilograms or anything like that. But what did we do up here? We said this -3 meant grams over centimeters, and this, so it's kilograms per meter to the -3. And you might actually find this example familiar, and it is it's because I've taken it out of worked example 3.7 out of the textbook. And if you check it up with the textbook, you come out with the right answer. Now, hopefully this will help you and figure out how this is done. I'm probably going to do one more, and I'm going to do a few examples with it. and spend a bit more time working through them, and hopefully you'll pick it up. I'll see you in the next presentation.